In this lesson, we'll apply an as-built joint. After completing this lesson, you'll be able to create an as-built slider joint. In Fusion 360, we're going to work with the supplied dataset, utility knife missing joints. We've already seen this file a few times before when we were just getting introduced to Fusion 360. This one is very similar, however, it's missing the joints that control the motion of the blade. So in this lesson, we're going to learn how to create that joint and how to manage those relationships. So to get started, I think it's important that we identify what we're working with. First, note that 4 of the components are grounded, and 2 of the components do not have that pin icon, meaning they're free to move about. We also have a joints folder that shows a rigid joint or a rigid group. This means that there is a rigid group between the components, in this case the blade and the blade cradle. So this tells me that both of those move together as one, which we can see here when we try to drag it around. But now we want to define the motion of the blade inside of the handle and be able to control that. To do that, we have 2 options: assemble joint and assemble as-built joint. The main difference between joint and as-built joint is the current location of the components. For example, an as-built joint will make use of the designed location or the current position of that component. A joint will require you to pick the reference locations as well as the components. For this example, an as-built joint works, and the motion created with either of those will be identical. However, the interface is slightly different. The first thing that I like to do is select the type of motion I'm interested in. Rigid will allow us to select 2 components and keep them locked together. Revolute will allow us to select 2 components and an origin and allow one component to rotate about that origin. The slider, which we're going to look at, allows for a single axis of translation. As we go down the list, we have more and more degrees of freedom: cylindrical, pin and slot, planar, and finally ball. So keeping this in mind, identifying the type of motion you're interested in is going to be important. So in this case, let's select slider. Then we need to define the components. I'm interested in the blade cradle as well as the left section of my design. Once those 2 are selected, it's asking me to select a position. The position is going to be a location or a reference, and in this case, as I move the cursor around, notice that there are selectable points that become apparent on the geometry. Also note that the reference direction is indicated by the arrow. So as I snap to an edge, notice that the arrow is pointing along that edge. However, on the face, it's moving up and down. Also note that once you're hovering over a selection, in this case a face, if we hold down the Control key, it will allow us to keep the focus on that face and move between all the available snap points. This is especially important as we get close to edges that share specific faces. So in our case, I'm going to go to this back edge, hold down the Control or Command key, and then I want to move to the forwardmost point. I'm going to select that as the reference point, and note that now the model moves back and forth. The reference point is important because it helps us better identify the starting and ending locations when we begin to modify the actual limits of our joint. We're going to take care of that in another lesson, so for now let's just make sure that we select that same point. Also note that after our selections are done, we have an option to define the slide, in this case the Z-axis, the X-axis, the Y-axis, or a custom direction. Because our part is defined along the default Z-axis, I'm going to select Z. But if we select custom, it'll then ask us for that custom selection. Keep in mind, however, that if we're making a selection of an edge, we should be sure that the direction of that edge is the exact direction we want the motion. In this case, either Z or the custom direction I just selected will be fine, and then we can select OK. Let's go ahead and zoom back out and check this. So now we're free to move the blade back and forth inside of that slot, but notice that it moves freely through the solid body as well. This is because we haven't defined the limits. Once you're done moving it around, let's select the revert position option to go ahead and put it back, and make sure that we do save this file before we move on to the next lesson.